Hi, I understand that some of the identities can be difficult, and it's hard to remember them, but you don't actually have to memorize all of them. Just get familiar with how to work them. For example, I'm going to take a problem out of the book. Problem number 64 in Chapter 5, Section 3. This is in the 4th edition, so if you're working off the 3rd edition, it might be a different problem number. And this is solving an identity, or proving an identity. But the idea is to figure out a way to get from this nasty-looking side to this nice-looking side. And trust me, when you get to calculus, there are going to be times that you're going to get something that looks something like this, and if you know how to turn it into something like that, you'll be done in half the time as the people who don't. So, let's take a look at this. First of all, we've got sine squared and cosine squared. Anytime you see something that is squared, note that what's inside, what you're taking the sine and cosine of, is the same. You should immediately start to think of the Pythagorean identity. The Pythagorean identity is, remember, I shall do this in a different color, sine squared, I'll put in alpha, plus cosine squared alpha equals 1. Now, that's all you need to know for the Pythagorean identity. Everything else that's based off of this you should be able to get using simple algebra. For example, 1 minus sine squared alpha equals cosine squared alpha. Or likewise, 1 minus cosine squared alpha equals sine squared. You can generate two additional identities based on this one. Alright? Now, what we have up here, we have a sine squared alpha, a minus, and a 1 minus cosine squared alpha. The 1 minus cosine squared alpha equals sine squared alpha. So let's take this top part and we'll divide it up into two sections. So now we have, and by the way, when you're working an identity, you don't have to just work one side. You can work this side, for example, and make it more complex, or you could work both of them and hope that you meet in the middle somewhere. In fact, if you're working it, going this way, and it's not coming to you, try working the other side for a second and something might click. Okay, so let's take that, and now that becomes sine squared alpha plus, from our Pythagorean identity, 1 minus cosine alpha is sine squared alpha. Alright, now let's look at the denominator. We have a 1 plus cosine alpha and a sine alpha, but the sine alpha is distributed. So let's distribute that now and just see what we get. Sine alpha plus sine alpha cosine alpha. Okay. That may or may not help. We'll find out. Working with identities is an experimentation process. But let's see what we can do with this. We can simplify our numerator and just make that sine squared alpha plus sine squared alpha is 2 sine squared alpha. And now our denominator. Let's see. Is there anything with Pythagoras that we can do with the Pythagorean identities? Not really, because the Pythagorean identities all use sine squared. Alright? Well, let's see. We can take and rewrite this. In fact, let's do it this way. 2 times sine alpha times sine alpha. That will give us our sine squared alpha times 2. And you know what? Now that I look at it, it didn't really help us to separate that out. So let's forget that we distributed that. Go right up here, put that back, sine alpha times 1 plus cosine alpha. And now look, one of our sine alphas goes away. So now we're left with something usable. We're left with 2 sine alpha over 1 plus cosine alpha. Now at this point, let's look back at what it is that we're trying to get to over here. This 2 we can take out of the numerator and just put it out front. Now we need to figure out how to get this sine over cosine to be tangent alpha over 2. Okay, so we've got this sine over 1 plus cosine. And if you look at the half-angle formulas, the half-angle formula says sine over 1 plus cosine is tangent alpha over 2. Alright, so this part would be equal to tangent alpha over 2. Wow, that's a really awful alpha. And then we just carry our 2 down. Okay, now, how do we do this? How do we do this with memorizing a minimum number of identities? First, we derived the identity that we needed from the Pythagorean identities based upon this initial one, which everyone from high school should remember: a squared plus b squared equals c squared. That is where this comes from. So if you remember this from basic geometry, this should be no problem, and therefore everything derived from it. Now, let's take a look at what else we can do with this. Okay? We also have, in the Pythagorean identities, 1 plus tangent squared equals secant squared. Well, let's take a look at this one in a little bit more depth. Tangent, remember, is sine over cosine. Okay? Secant is 1 over cosine. Now, watch what happens when we multiply this whole thing through by cosine. We're multiplying the entire thing by cosine squared. We get cosine squared plus sine squared, because a cosine cancels with that cosine, equals 1. Notice, it looks kind of familiar, doesn't it? So, that's one way of deriving the second set of Pythagorean identities based on the first. You can take and manipulate these any way you can using basic algebra to figure out what you need to do. One thing that might help to clear up the visual clutter is to just take and replace the sine alphas with letters. Let's take a look at our original problem again, this time without some of the clutter. Let's say we're looking at this and we're having a hard time figuring it out. Sometimes it might help to say, okay, I'm going to say over here, sine squared alpha, I'm going to call that u, for example. Then I can replace over here u squared plus, and let's say cosine squared alpha equals v. 1 minus v squared alpha, or sorry, v squared over u times 1 plus v. Actually, I'm just going to make that, okay. If sine is u, cosine is v, then we can just transfer it like this. Sometimes this might make it easier to see. If that helps, do it. If not, forget I said it. Other tips is really just to break down the identities into their basic forms. You can take the power reducing formulas for, say, sine squared equals 1 minus cosine 2 alpha over 2, and you can get those as a result of the Pythagorean identities. I'll work on that and get it back to you for next week. Okay, well, I hope you found this helpful. If so, let me know and I'll make more. So, have a good night and good luck on your next test. Thank you.